Getting started. Okay. So welcome to the Argonaut review of 2023. We have 60 minutes and 6 projects. And so we're going to get going here. For folks who may not be familiar, just a quick level set, the Argonaut Project is just a mix of technology vendors and provider organizations looking to accelerate the FHIR exchange in healthcare. Here's a quick picture of our membership mix for folks who may not have seen this before. And in terms of project timelines, we're not too fancy with timelines, but this is how we ran the projects last year. And up first, we're going to run through Argonaut imaging with Josh Brindell.
Awesome. So I'm going to grab the screen share and then give it back to you once I finish up. And just to confirm, Brett, as long as we're done by 20 minutes after the hour, we'll be on track.
Yep, you got 7 apiece. Good.
Perfect. So the first project we're going to talk about is access to imaging. And one way that you could articulate the problem here is that people have all kinds of devices that you can't stick a CD into, and yet images are on CDs. So how do we get access to images? That's one way that we could talk about it. But more seriously, the problem statement that we had for this project was we want to make it easy for smart apps to get access to imaging studies, just the same way that they can already get access to clinical data. And in particular, we know that apps have users who are sitting at the keyboard or at the tablet or phone screen, and those users have precious little time and energy. And we want to make sure that if users are going through the trouble to sign in and grant access to their health data, that they only need to do that once. And if they've got imaging data inside of a health system that's sitting right next to their lab results and their clinical notes, patients and clinicians should only have to go through that authorization process one time, and an app should be able to access that full set of data. Anything that the user wants to share should be able to come along for the ride. And there are many use cases for using imaging data alongside clinical data. This is not a comprehensive list, but just to point out, there are some that really matter a lot to patients or healthcare consumers. So this could be anything from trying to access and understand your own data just by compiling it in one place. It could be looking for a second opinion or getting a specialist consult where that provider needs access to the imaging data alongside your clinical history. Or it could be donating a data set for research, maybe for a disease that you or a family member might have. On the provider side, there's a lot that might be integrated at the point of care. So on the one hand, you might want to use specialized tools that can make sense of specific imaging modalities and compute risk scores or disease severity. And that kind of information can require the pixel or voxel data from an imaging study, as well as lab results and other clinical inputs to the risk scores. And on the provider side, this can also streamline kind of consultation workflows. So there's a lot of use cases here, but really anything that people want to do with their images should be fair game. And the project that we ran this year started with a specification that was developed a few years back with funding from the National Institutes of Health as part of the All of Us research program. It was done before the current versions of SMART were available and before some of these imaging resources were widely used. So we used this as a starting point, but we led a project to expand and improve that spec and make it work smoothly with the current versions of SMART. And essentially what this specification does is to provide a way for a SMART client to discover information from a FHIR server about where its imaging server might live. I won't go through the kind of workflow in detail, but I just want to point out that the spec includes kind of this overview of the various steps that are involved. But at a very high level, a SMART application can talk to the FHIR server. It can say, hey, where does your imaging data live? And then that client can talk to the imaging server as well as the clinical server using the same access token. And we profile a very, very narrow set of the DICOM web APIs to make this work. In particular, there's really just 2 imaging-related calls that a client needs to be able to make. The first one is, tell me all of the imaging studies about a given patient. And it gets back a FHIR bundle of imaging studies, just the metadata about those studies. And the second call that it can make is, hey, please fetch the full contents of this particular study that I'm interested in. And with just those 2 API calls, you can already build quite a lot. So over the course of this project, we fleshed out some of the capabilities for how this discovery can work, how an app who's talking to one FHIR server can ask that server, hey, what other affiliated or associated endpoints might I want to talk to if I want to get imaging data? So we built out that capability, and we wrote out FHIR profiles for exactly what fields of the imaging study and endpoint resources to populate in making those interactions work. Over the course of this project, we also put together a demo environment that integrates with an open source sandbox, as well as with the Epic sandbox, and is extensible to other endpoints as well. There's work in progress for Cerner and Meditech already. But I just want to show you the user experience that we're aiming for. So you could imagine this as a patient-facing app that's running on a patient's phone, or you could imagine this as a clinician-facing app that's integrated into the EHR and embedded into that EHR real estate. Either way, that app can connect to an endpoint that you choose, and there's an OAuth approval process. So for patients, there's an explicit step here where patients would be asked to sign in and approve exactly what data are being shared. And then this app can talk to two different FHIR servers. One that it's using to populate this pane here that says EHR data, and that's got things like patient demographics and medications and allergies, all the stuff that's in US Core and widely deployed as part of certification today. And then this second pane here has the results of talking to an imaging server. So far, we've just done a request to get all of the FHIR imaging studies, and we get back that bundle of studies. And then if the user selects a given study, like this arm X-ray, then that entire study can be fetched using the DICOM web protocol and made available locally. So by the time I've clicked that, all these images have already been loaded in full diagnostic quality into my web browser, and I can switch easily back and forth between the different series in that study. So that's the kind of user experience that we're looking for. One authorization flow that provides access to both of these sets of data side by side. And for folks who are interested in more of a technical deep dive, I'll include a link to a presentation that I did at the last Dev Days conference that goes into the details of the API and of the reference implementation. After we put together these updates in the spec and built this demo environment, we also ran a virtual connectathon. So we had participation and some connections between app developers and PACS systems. We had a team from Apple that was putting together kind of a small reference demonstration that was able to connect to our reference system and I believe to the Philips backend PACS system as well. So it's been still early days, but we've demonstrated that these APIs for authorization and data access work here. In terms of next steps, one that's underway already is incorporating this discovery capability into the Smart App Launch Implementation Guide. This was something that we needed for the imaging project, but it's also something that's emerged from other projects in the community as well, to be able to associate a set of endpoints with a FHIR server. So that capability in terms of Smart App Launch Discovery is now in ballot in the current cycle. And so hopefully we'll land that in the next publication of SMART. That's the 2.2 release. The other next step that we're focused on is finding clinical sites that want to try this in production, and ultimately looking for ways to scale this where PACS vendors or other imaging integration systems can participate. So that's the quick overview of imaging access. And I'm going to run straight into patient access brands next. Some of you may remember this is a project that we actually ran last year, and we put together a specification that would help EHR systems publish a set of FHIR endpoints, but not just the endpoint locations, also information that patients would need in order to find their healthcare provider in what could be a very big ocean of health information. So we put together the profiles to allow each endpoint to be associated with various branding details that the healthcare organization might use and the patients might recognize. So things like names and logos, and also recognizing the complexity of healthcare organizations, which can merge and split. And sometimes you have one healthcare provider organization offering technology services for other organizations within a region. So we wanted to be able to express kind of all of that in a consistent way. At the end of the day, the goal here is to make it very easy for patients to use apps that offer this kind of connect to my health records user experience, where the patient knows the system they want to connect to, and they can easily find them based on location and other parameters. So we put together this spec last year. We ran a connectathon. We had pretty good success testing this out. But there are a lot of moving parts in this domain. And one piece of feedback that we got was there are other specifications that were profiling similar FHIR resources in slightly different ways. So we wanted to take the opportunity to really align this work with other external content that we saw being developed. We also got a hint from ONC in the HTI-1 proposed rule that there was strong interest in ratcheting up the requirements for this kind of discovery. So over the course of this year, we made some improvements to streamline our profiles to say, make it as clear as we could that each organization that a patient might want to connect to might have one or more patient portals that enable access to one or more FHIR endpoints. And we realized that if we were going to see broader adoption on this specification, it would be important to have it published in a way that the community could easily find it. So we've incorporated this content into two places in the standards world. One is in the Smart App Launch IG, and this is kind of the home where we describe how the specification works and provide examples that are modeled after realistic scenarios. And we were also encouraged to take some of this content models and publish them as core FHIR extensions. So you'll see that some of the content models we rely on are now landing in what's called the FHIR Extensions IG or the Extensions Pack. These are extensions that we use to associate branding information and patient portal information with a FHIR organization resource. All of this content right now is up for ballot in this cycle, the January ballot cycle. And I'll just do a very quick tour through it so you can get a sense of what's there. If you want to do a deeper dive, you'll know where to look. So in the SMART implementation guide, this shows up in the header right now as brands, and it's got this little new badge next to it. This takes you through the overall user experience and data models that we use to represent these brands and endpoints. And essentially, this screen sort of tells the major story that each brand is associated with a set of information that consumers can recognize and a set of portals where patients might be able to connect and approve access to their own data. I won't take you through the details, but I just want to sort of lay it out here. And then in terms of what the actual data look like over the wire, there are some annotated examples that show you, for example, how the Good Health organization might publish its patient branding information. So this is a FHIR organization where we have a code system that's particularly relevant for patient-facing apps that can tell those apps what type of data are going to be available here. And we have a very small taxonomy of data that says things like, this is going to be clinical data, or it's going to be healthcare financial data, or it's going to be laboratory data, those kinds of things, so that when you're connecting to a national lab, you can display that sort of information versus a healthcare provider inside of a patient's app. And then we use FHIR extensions to represent the core branding information for the organization. So in this case, that consists of a logo, which here is an SVG, and we have some user experience guidelines about the sizes and data formats for these. There can be a license about who's allowed to use that logo or how it can be used. And there can be a link to more detailed branding information. So that's the core extension that we use to attach branding information to an organization. And then the other interesting thing that happens is that Good Health organization can be associated with one or more portals. So in this case, there's one portal whose name is Good Health Central. There's a description of that portal, which says who it's for and what patients can do there. And this becomes really important for larger organizations that might have more than one portal that applies to different subpopulations of patients. It's really important that patients navigate to the right one in order to get their own data. And that portal has the URL where patients can see it online, as well as logo information associated with it. And then at the end of the day, these things are associated with FHIR endpoints. So we link out to the endpoints. And the reason that I say endpoints plural is there could be more than one. Maybe this health system offers a FHIR R2 and a FHIR R4 endpoint simultaneously. And access to both of them can be controlled from the same portal authorization screen. So that gives you kind of a flavor of what's involved in the patient access brands spec. And the other page that I'll just briefly point out is the examples page, where we go through some simple and more complex cases. So there's 4 overall that we walk through in detail, where we show you the kind of thing that a patient might see inside of a patient app, and talk through things like what happens when an organization merges or splits, and the information might be published as part of 2 different EHR reports. So I will wrap up there. Happy to answer questions in the Zoom text chat and of course on chat.fhir.org.
Thanks, Josh. Up next, we have FHIR Vitals with Dan walking us through it.
Great, thanks, Brett. So I'm gonna do a quick overview of two projects we did. The first is around writing vitals data from a smart on FHIR app back into an EHR or other FHIR system, and we had kind of three use cases in mind when we talked through this project. Three driving use cases. The first would be a case where a patient where a provider has ordered home monitoring for a patient. So this is a case where the healthcare organization is interested in receiving vital signs from the patient and is able to review them kind of between visits. So in this case, a patient's blood pressure cuff might send data to the patient's phone, other devices also, and then that data the patient can log in using their smart on FHIR authorization from a phone app and write that data into the healthcare provider's EHR, and then the EHR would then kind of have a back-end workflow where that data could be associated with the order for that patient and sent to the provider. And so in a case where the patient doesn't have that order, the EHR may say you're not authorized to write these vitals. Second use case was a provider-facing use case where you might have a blood pressure cuff at a healthcare institution that needs to integrate with an EHR system, and you don't want to necessarily have to do a custom integration at every site, and so you could use Smart on FHIR and FHIR Write to be able to do that in a standard way. And then a third use case is kind of a little bit parallel to what Apple Health is doing today, where an app will write data into a repository that's kind of controlled by that app developer, and so that data might be coming from devices or might be input directly into the phone. It might be tracking your steps, something like that. And then when the patient is seeing the provider can use a Smart on FHIR app that's embedded in the EHR to access the app repository and pull the data into the EHR. And so today this is done through either proprietary APIs or through copy and paste. And so we wanted to think about how we might do this in a standards way. And then one thing I neglected to mention is that we really focused on writing the US core vital sign profiles, observations with those profiles into the EHR. So in this case, we weren't trying to define new profiles, but really take what we already can read and figure out what the right side of that would look like. So next slide. So we came up with a draft spec, and where it's living today is in the future candidate requirements under consideration section in the version 7 of US Core. And I wanted to highlight a couple of the kind of interesting aspects that came out of the calls that we did and the work that the Argonaut members did. So we defined smart version 2 scopes for writing vital sign observations, just to have that listed. Also defined a tag to indicate that the data is patient supplied that can be attached to these resources as they're written into the EHR or into the clinical system. And the goal there was to enable EHRs to display this data kind of separately if they, because it might have a different level of trustworthiness than data provided at the clinic, maybe higher if you believe that the patients are going to have more realistic blood pressures at home. And we wanted to be able to segregate that both in the EHR and in subsequent accesses by apps. Actually, after we finished the project, or finished the calls, there was a suggestion that we could use this tag on the meta.security section of the resource instead, since there's already a tag that indicates data is patient supplied. So that's certainly something that we're going to look at shifting to in the future. We added guidelines around kind of how to populate the resource. I won't go into too much of that in the interest of time. We also added some guidance around how EHRs can handle high frequency data and duplicate observations and when they're allowed to kind of drop data that's written, just so that we're all on the same page around that. We really focused on creating resources, but we also had one scenario where we wanted to define a behavior around modifying modifying observations that were written already by an app. So an app modifying its own observations, and that was to be able to tag them as entered an error. So the use case here might be if a patient writes a bunch of data, but they're acting as a proxy, or a user writes a bunch of data, but they're acting as a proxy and they selected the wrong patient in the EHR, they might want to mark all those observations as entered an error and then resubmit them to the correct patient. We defined how bundle resources could be used to indicate that a set of observations should be kind of grouped on the back end. And then we spent a fair bit of time talking about how you can use provenance resources to track either the most recent step of who created the data, as well as kind of which apps touch the data. So which users touch the data and then which apps touch the data, either as just the last step or kind of all the prior steps. So there's guidance around that as well. And then last slide on this, Brett. Yeah, so in terms of next steps, next step is implementation. So we did a Connect-a-thon in November and tested out some prototypes and kind of early implementations of this by folks. And so I think a great next step would be to start to do more production implementations and get more experience there and update the spec in US Core as it would make sense. And then of course we want to, I think there's a lot of interest in writing other data into EHRs as well. And so we want to take what we learned here and kind of apply it in other write projects. Just like in the Vitals project, we took advantage of some of the earlier work that Argonaut had done on how to write FHIR resources. And so we want to kind of continue that and keep building our knowledge base about what sort of guidance is useful when folks are implementing write for FHIR resources. And then next slide. Yeah, so the other project that I wanted to talk about was actually a mini project. So I think this ended up being 5 or 6 calls rather than kind of a full-length Argonaut project. And we wanted to kind of sketch out very quickly what it might look like to have to do secure messaging between an app and an EHR. So instead of kind of only supporting messaging for patients with a proprietary app that's tied to the EHR, what would an open standards-based implementation of this look like? And we had 2 use cases that we were thinking about when we worked on the project. The first was a way for third-party portals to integrate with the EHR. So kind of mirroring the function that can be done in kind of a captive portal now, but being able to do that in an open standards way so that healthcare institutions could implement different portal solutions as it made sense. And then the use case that I found pretty exciting is around patients who want to share information from an app directly with their provider and get feedback without having to kind of take a screenshot, flip into another app, log in again, paste in the screenshot, and then kind of check that other app for response. So I think it's kind of a neat opportunity to have kind of semi-structured data exchange without a lot of kind of overhead or infrastructure. Next slide. Implementing an email system is kind of an unbounded project. So we spent a lot of time at the start of the project talking about scope and what's in scope and what's out of scope. And I wanted to highlight a few of these items because I think even more than kind of the output of the project, this really was kind of defined what we built or what guidance we came up with in the project. So one of the things that we talked a lot about was really around how do you tell the app who the potential recipients for a message are. And in some cases, you might not want that to be everybody in your institution, probably all cases. You might really want to constrain it to a care team, and you might not want to have individual providers. You might want to have departments, or you might want to have some providers, some departments. So a lot of complexity there that we wanted to make sure we addressed. We absolutely wanted to make sure that if there's rich text in some part of the communication messaging chain, that got persisted through. Even if from a write perspective, we only wanted to support plain text data. So had to be able to display rich text if it went in so that information wasn't lost. There were a couple different models that different participants had. So we wanted to be able to support both a fully threaded messaging model and an inbox model. or where you can, sorry, a chronological inbox model. So where you have kind of, where the messages don't have threads necessarily. And then we wanted to support both, kind of similarly, support both email style messaging with a subject and a body, as well as kind of text message style messaging where there's no subject, it's just some, just the body part. One thing that came up was making sure we had a way to differentiate between the person sending the message, who might be a proxy, and the patient who the message was about. And of course, we wanted to make search parameters flexible because different systems have different approaches to searching messages right now. We left draft messages out of scope and kind of said every app's going to store its own drafts, but there won't be a central repository for those. And then we also left out of scope kind of defining which proxies can view a message. So I think where we landed was basically apps should inform the patient that if they send a message using this mechanism as it's defined, everybody who's a proxy will also be able to see the message. And that was really just to sidestep complexity in kind of a initial set of guidance. Next slide. So we ended up creating kind of a draft spec that's posted online. I won't go through, in the interest of time, kind of a lot of the details of the spec. We profiled the communication resource, and so the way messaging works really is kind of reading and writing communication resources. Some parts of it we defined as kind of auto-populated by the server, either on an optional basis or required basis. So the date when the message is when the communication resource is created is the date when the message is sent. And so an app can create a message by writing a communication resource to the server and potentially including things like the in response to element to indicate that it's a response to a message that was previously created, and those would also show up as communication resources. Next slide. I'm sticking to my time. So I wanted to highlight two of the observations that we defined as part of this project, because I think they kind of indicate some of the priorities. So one of those was a get reason choices operation, which lets the server, or lets the EHR kind of define a set of potential reasons that the patient can pick from. So this is kind of the idea of being very flexible in terms of what clients are able to put in the messages, so that servers can kind of predefine ways to route the messages. So if there's a set of choices that help the server route the message, those can be provided to the app to include with the message. Similarly, I talked a little about some of the complexity we discussed around recipients. And so where we landed was really letting the server, it knows the logged in patient or the logged in proxy. And so it can use that information to provide a set of recipient choices, much like the captive portals do today, and let the app select from that list. And so those are a set of FHIR references that, at least they'll have a subject and an ID, or a text and an ID. And so the app can display the list as it comes from the server, let the patient pick, and then the server on the back end can take that message and route it however makes sense from a business rule perspective. And that might even be specific to a healthcare institution. And then last slide, Brett. Thanks. And so in terms of next steps, implementation. So Meditech implemented the draft spec and had some feedback. We had a great meeting about that, I think end of last year. And then this is a very, very rough spec. There's clearly a lot of ways that it could be refined, both through implementations and feedback, and also just kind of spending more time going through the details. So I think that's kind of a potential project that's out there if folks want to refine that. And then one thing that we didn't really address in the spec that's clearly a need is this is almost a perfect use case for subscriptions to alert when new communication resources are waiting for a client. We left that as kind of undefined in the spec, so you can either pull on the REST API or define your own kind of subscription infrastructure to support that. But I think that would be another thing that would be really great to standardize if we revisit the spec. So I'll leave it there. The spec is on HackMD, so it's publicly available, and I think it's linked to from the slides as well.
Awesome. Thanks, Dan. Up next, we're going to talk about an assessment sprint we did earlier this year, and Eric's going to lead us through it.
Okay, can everybody hear me okay? I hope so. I wasn't realizing. I think I was off mute
You're good.
before, but
You're good.
okay, good. Okay, so the assessment sprints objective. So just to address what we were trying to address was a problem where we had I think it was US CDI version 2, I believe. We had SDOH come in for SDOH is structured, I'm sorry, social determinants of health, and that was involved a lot of assessments and screenings. And we had through US Core, through that version and subsequent version, kind of had an ongoing struggle to define how to come up with a single approach in US Core to represent these assessments, observations versus question response versus both. And we kind of wandered back and forth on what was the best approach. So we decided to have this assessment sprint to nail down the minimum requirements. So we also had like shall versus should for certain profiles and objects to record and transform these assessment results. So our idea here was to nail down the minimum requirements for screenings and assessments. And and we were doing this because we wanted to create a general approach, because although we started out with SDOH, we now have have a half a dozen more assessment type domains in the latest version of US Core. So like we say here, there was no real consensus on a general framework for screening and assessments, which included the USCDI requirements for these four different domains. We have added 3 more since then for the latest version of US Core. And so we went into this trying to answer these simple questions. What does system support today? And what is the minimum requirement for systems using US Core? So, and we want to finalize that approach. So our design goals, of course, was to get implementer consensus on the screening and assessment requirements. Like, what objects do you have to, show, and what's the requirements, and also to provide some meaningful guidance on best practices, and go ahead and document those requirements in US Core. So, so our solution was we had a couple of ad hoc discussions during the January work group meeting to get things kicked off, and decided to go with a series of formalized calls during the spring of 2024, trying to, and our timing was also coordinated with ballot reconciliation for the ballot of US Core, and then prior to publishing in the May time period. So basically, the solution was to rewrite US Core screening assessments page guidance to clarify our implemented requirements, kind of nailed this down. So we came to the conclusion that we really, basically, the only real hard and fast rules you shall require supporting clinical judgments, an assessment as a clinical judgment using our USCDI data class health status and assessments for USCDI using either an observation or condition. And you should support the questions, basically, that you're asking to arrive at these judgments using observations and question response. And then we provided informative guidance. We reached out to the structured data capture team for some more insights and guidance on using question response, and as well as the benefits of that, and the pros and cons, basically, of question response versus observation, and tried to provide some guidance as well in that direction. And like I said, so we have I think we've come up with in US Core, I think, a good way to capture the entire idea of assessments and screenings, and providing what we feel is a good baseline support of profiles to represent assessments. And we've applied, again, like I said, we applied in the latest version, we applied 3 more domains to that framework. So, okay, so then we have this other project we've done now for, I think, 3 well, we've done it several years. I'm not sure, 3 or 4 years, where we've taken an early look at the USCDI version 4 requirements and had what we call design sprints, where we come up with the initial designs for some of the USCDI requirements. And our objectives are to, if we need to, design US core profiles to meet those USC CDI requirements. And in the last year was USCDI 4, version 4. And this helps seed the initial design discussions for the next version of US core, and seed discussion for as we go into the fall. We take our initial design approach and we present it to the HL7 community for further refinement. And we also have an opportunity at that stage when we're in this design framework to provide some meaningful feedback to ONC. So the design goals are to define a minimum set. So I want to emphasize minimum, that's why it's bolded there. Minimum set of requirements for each of the US core profiles to meet the clinical use and certification requirements of USCDI. We allow, and we do this, and we with an eye towards allowing further refinement for other standards work. So we want to create a baseline, but we also recognize that doesn't meet every use case. We want to make sure that these profiles are also something that you can build upon to create more domain-specific profiles. And more and more as USCDI has progressed, we're leveraging existing work where we look for other projects, other FHIR accelerators, other projects in the US realm and even abroad that have tackled similar domains to try to give us a kickstart. And then through our discussions, through several meetings, we come up with a single set of proposals prior to the HL community design discussions. And then eventually we take those designs, refine them, and publish them in the next version of US core. So some unique things about this year. We've done this, like I said, for several years in a row through Argonaut, but this year we have an earlier kicked off. In prior years, we tried to wait until the draft USCDI requirements were finalized, but we realized there's very few changes historically that have been made between draft and final. So we've got an earlier kickoff. We started out this year in May at the HL7 with a HL7 work group meeting in May, with a couple of quarters devoted to, I think we had 3 or 4 quarters devoted to an initial outline of a design and going through some issues with ONC present. So we're actually kicking off while it's still in draft, with the hope that with ONC present, we at that point we could make some meaningful comments before the final version. So then we have a series of around 10, maybe 8 to 10 meetings in the summer with really healthy discussion and participation by vendors and systems and other stakeholders. And then when we're finished with the designs, we try to get finished in a rapid iteration through all the ONC requirements. And then we present that to the HL7 community, typically formally at the September working group meeting. And then we have subsequent meetings generally in the fall, prior to publishing the US core ballot version, to help refine and get community discussion before we go into the ballot. And then post-ballot, of course, we have reconciliation with further comments and publish in May. So we have links in here to the US core artifacts, and I will be repeating this for USCD version 5. So let's see, next steps. So we track the ballot, so we track HL7 ballot reconciliation, and consider testing sprints on topics where there's no consensus. We talked about the assessments. That's one topic. Last year we had a design sprint. This year we're gonna probably take a look at granular scope section 2, because that's a new part of US core that we do want to get some further feedback, maybe beyond the ballot. And we do plan to do this again this year if there is, and there likely will be, a USCD version 5 coming out, and we'll probably kick it off in the same time frame from May through September. Brett, is there anything you want to kick in here from your perspective?
No, I mean, I think the success of kicking things off early is going to carry forward into this year. And so for folks who are watching we got the ONC HTI1 rule that came out in December. We expect USCDI draft V5 in January, and we look forward to digging into that fairly soon after it's published, because we know the momentum we built in the spring served us very well as we went into the fall. So in my mind, thank you very much, Eric, Dan, and Josh. Argonaut, we joke we don't make the FHIR as you deploy, we make them better. And I don't know how you listen to your podcast, but I was thinking about listening to them on speed, and then thinking for folks who watch this recording later, you may not be able to watch it at 1.2 or 1.5. You could try, but I know with how quick we talk and try to move through things, we want to be efficient with everyone's time. But just to reflect on the year, there's 6 projects here. The idea that a patient has a way to access their images, still work to do there, but very promising. Patient access brands was mentioned in the HTI1 final rule from ONC, and we're optimistic with some refinement that will get kind of further promotion. Secure messaging from an app. It was really fun this year to have a vendor develop side by side as the spec was being developed, and we typically do have that experience. Argonaut's very committed to real implementation work as we go, and we get a lot of that in the pilot environments, but this was actually being deployed, so that was very exciting. FHIR Write Vitals, the sky's the limit on Write. We as a community get asked about Write in a whole variety of use cases, and I think as we go through kind of project selection this year, there's a pretty good chance that we will have a Write project this year. And of course, the US Core, USCDI design sessions, I think we learned so much in the assessment sprint in the spring of last year. And, assessments are hard, and we learned that there's a variety of ways which sites do them, and think of a pretty good design framework that is standardized and available for you. So for those of folks who are here today, thank you for your input. The members, I always, in my mind, I think like the Argonaut members are the best members, and the community around it has been incredible. Argonaut is 9 years old, and in terms of projects selection this year, we're in the middle of it, and we expect to kind of publish that what's selected hopefully in February. We have a draft list out that we've shared around, but with that, this kind of closes our Argonaut 2023 year in review, and I will pause the recording. Well, what do you folks think? We could take questions now, or I'm just going to stop the recording here, and then